So we recently did a video on how to build a simple SR20 engine. One that would be like totally reliable on the track under pretty hard use from in between 400 to 500 horsepower. But one good thing about the SR20 is it's a super strong engine. So we're going to do a series of videos on how to build the ultimate full bolt-on SR20. So we're going to use this for a S13 that's in the background over there. But it's going to be a kind of unique car. We're going to try to build a car that's decent at drifting and decent at doing road racing and time attack. So we're going to probably be trying to run this in GridLife's GLTC class, do some time attack, maybe Nissan Cup stuff, and do some drifting for fun. It's probably not going to be a competition drifting car, but for drift days and just goofing off, it'll be pretty good, I think. So we're going to target maybe about 330 super reliable, low stress horsepower. Try to avoid all the SR20 pitfalls like bad oiling and spun rod bearings and overheating. But these are like maybe the basics of what to do. And these basics here can probably easily get you all the way up to 400 horsepower with the totally stock bottom end. It just depends what your turbo choice is. But we're kind of building for fast response, good torque, and maybe not so much top end, and fun track day car, not the ultimate stock bottom end SR. And we've done that before. I think our record was 420 horsepower for a totally stock bottom end, and that car lived for a pretty long time. But you know, there's one thing living on the street and blast down the drag strip and living on the road course or living drifting, a whole different level of stress. But we're going to talk about the basics in this video, and we're going to talk about a lot of the peripherals that are needed to build a race type stock bottom end SR and some other videos that will be coming. So with that being said, let's talk about the basics. So one of the first things you want to do when upgrading your SR20 DET to make more power with a stock bottom end is to upgrade the turbo. The stock T25 spools quick, works really good at the low boost that it runs, but when you try to up the boost too much, it makes a lot of back pressure, and you run the turbo right off the compressor map and you blow hot air into the engine. Neither one your engine likes very much. So first thing we did is upgraded the turbo to a Garrett GTX 2863R. Now this is a really cool turbo. It has the same footprint and it's about the same size as the stock T25, but it's all new technology. It has a ball bearing center section. Ball bearing center sections have about 20% more efficiency than the old plain bearings, which equates to about a 500 or 600 RPM improvement in spool time. It also has more contemporary aerodynamics in the compressor and turbine wheels, and which equates to more flow and better efficiency. Now for low 300s to mid 300s, this is probably the turbo. It'll spool about the same as the stock turbo, but just make a lot of power. So a lot of you probably have heard of the Disco Potato Turbo that Dave Coleman, Dave Kavanaugh, Rob Cadle, and I came up with in the 90s. That kind of was the dominant upgrade turbo for these engines. You know, made power, spooled really quick. Well, think of this turbo as the Disco Potato on steroids, and it's the next step up. So it should have quick Disco Potato-like spool and make even more power. One of the things is we got the turbo with the optional .86 housing. This .86 is the A over R, and it's on the big side for a small frame turbo like this, but this turbo will be efficient and spool faster with the bigger housing, and it makes a huge difference in back pressure. The stock housing is a .63, so it's a whole step up from that. So more efficiency, quicker spool, and less back pressure and less heat getting pumped in your engine. All good things. We're sticking with the internal wastegate just to keep things simple and the packaging tidy. You know, this level of power, you don't exactly need to go into an external wastegate, but it's pretty nice. Another good thing about this turbo is it has a ported shroud compressor housing. You can kind of see by this venting around the outer part of the housing. And if you look, there's a groove right past the inducer of the compressor wheel. Now what a ported shroud does is it gives you more surge margin. So surge is that chirping noise that sometimes you hear when the car shifts or the throttle's let off, or if the turbo spools too quick and it makes boost more than the engine can swallow, I guess. It'll surge and chirp. So when you have chirp, it makes an incredible load on the thrust bearing of the center section and puts a lot of stress in the compressor wheel too, and could possibly cause the compressor wheel to burst. So what the ported shroud does is it lets some of the air getting sucked into the turbo. If there's a backup in the system and it's approaching surge, that air can go through that slot, go out through the vent, and then back into the compressor. So this kind of like helps bleed off some of that excessive flow and reduces the propensity to surge. This can help your reliability quite a bit, and it can make it so you can have a really fast spooling turbo like that without risking damage to it. So the ported shroud's a good thing to have. Some of your more advanced turbos have it. This has it. The Disco Potato didn't. The only disadvantage to a ported shroud is sometimes you give up a point or two of compressor efficiency, but if you look at the compressor map of this turbo, it's super efficient and it didn't really hurt it. So all good things. Now a really good turbo won't be as effective without a good turbo manifold. And we got this ISR brand of turbo manifold. It's sold by Intercooler Racing, and they have their own internal brand called ISR. I'm actually really impressed with this manifold. It's fairly economically priced, but it has a lot of cool features that usually you find in way more expensive manifolds. The first thing is a machined water jet cut thick flange. So this flange is nice and thick. You're going to get good gasket seal, no warping. It'll be hard to get exhaust leaks that can cause your turbo to lag. Good quality flange. It has pretty thick tubing. It's not exactly equal length, but it's pretty close to equal length. And there's a lot of reinforcements. So everywhere these things have been known to crack, from like the tubing to the flange, and from the flange to the tubing here on the turbo side, is reinforced. It has really good quality TIG welds, really nice welds. And another cool thing that I haven't seen in any of these stock position turbo manifolds is this brace. This brace is really cool. It connects the flange to the flange to flange, the exhaust to the main flange. So this thing's totally reinforced. It's not going to crack. The other cool thing is, you know, this is a pretty inexpensive manifold, but the collector is like merged. So all the tubes are precisely mitered into each other and welded on the inside and the outside so they won't crack. And then they're also hand blended. So really nice features found on expensive manifolds. Every exhaust port is hand blended into the tube. It's also stock position. So like, you know, if you can't afford to buy all the things, you can upgrade your car modularly. So the stock turbo will go on here. Some of these bolt-ons like the Garrett will, and almost every aftermarket downpipe and charge pipe and all that will fit. So this will work with stock stuff, any lash up of stuff designed to work with stock, and with our cool upgrade stuff. So, I mean, I think this is a really good manifold for the price, and shoot, I would run this over some of the expensive manifolds on the market. Another thing that's important that often gets ignored is ISR makes this cool heat shield for your master cylinder. Now these SR20, S13s are kind of designed for the Japanese market, where the driver and the master cylinder is on the other side of the car. But for the US market, that hot turbo is right by the master cylinder. And if you don't want to fry it, having this heat shield is really important. So we used to have to fabricate these and you know, make them. And you know, some people can do it with varying degrees of success, but you know, ISR and Juku makes this easy. You can just buy it, bolt it right on, no fabrication, quick and easy, no excuse not to run one. Another cool thing is ISR's O2 sensor housing. So this takes the place of the stock elbow. The stock elbow does this sharp 90-degree turn, and it's all restricted inside. The ISR part has like a lot of room. It's investment cast, stainless. It's really smooth. It goes from the stock 5-bolt flange to a nice big 3-inch. It's all smooth radius, so you know it's got to flow good. That's one of the advantages of this over some of the fabricated ones. There's no way a fabricated one made out of pieces of pipe welded together is going to be this smooth and this good flowing. ISR also did a lot of attention to detail. They made sure there was clearance for all the nuts and wrench clearance, so you can get a wrench and tighten all these things pretty easy. You're not going to have the stud sticking out and hitting this and having it not able to seal and having to grind nuts and grind studs and cutting your wrenches to be able to tighten this like some of the other things we've run into in the market. So nice, simple, bolts on nice and clean, flows good, high quality, it's stainless. I forgot to say that all of this ISR stuff is stainless. One of the cool things about stainless is it has half the thermal conductivity of steel. So in the case of the manifold, there's more exhaust energy heat going to drive your turbo to help it spool quicker. And then the stuff after the turbo, there's less radiating heat to make things cook off in your engine compartment. So the O2 sensor housing makes things easy. Direct bolt on, no messing around, which goes to ISR's downpipe. This is a nice piece. It goes from 3 inches at the flange to a little bit more than 3 inches. You can kind of see it has this nice smooth step up. It's all mandrel bent, so it's one piece. Nice thick flanges that aren't going to leak, and really nice TIG welding. It's also like finished nicely. This is a great piece. I'm really impressed. Especially the price of ISR stuff is really competitive, and it just really impresses me what kind of quality they're able to deliver for the price point. And you know, this car is going to see hard drifting and racing mileage at the track, and I have no qualms about installing it. It's all good stuff, and I'm amazed they could sell this for that price. One of the other things that's a pain in the ass about upgrading your turbo is finding all these kind of hard to get SR20 DET parts that aren't really available in the United States. I mean, you can order them from some of those Japanese websites, but I mean, ISRs in the States has this stuff in stock. Like they make an install kit, which is right here, which has all the gaskets, O2 sensor plug, oil drain, all fabricated. You know, you don't have to mess around. It's ready to bolt on, and the oil feed lines. So that takes a lot of pain in the ass out of upgrading your turbo. I mean, everything's all pre-cut, pre-terminated with all the right fittings. You know, it makes it more of a no-brainer, easy upgrade. So, you know, here's our group here of stuff, and maybe some of you guys might want to just stop, you know, right there because that'll get you pretty decent power. But this is a group, Garrett Turbo, ISR, other parts. It's all really good stuff. No qualms about using it. Some of the other stuff, when you're getting more power, the stock Nissan injectors and fuel pump are totally inadequate. And some of you guys might only want to upgrade the injectors and pump. We're going to be doing the whole fuel system, but we don't have enough time to get into that right now. And you don't have to do all that stuff, but we'll show you the minimum that it's going to take. So we have a set of Dishworks 1200cc injectors. Now this is a really good injector at a really good price point. Dishworks makes all the stuff to adapt it to the Nissan, but the basis of this is the Bosch Motorsports EV14 injector. So it's a well-known injector that a lot of tuners know the characteristics and the invalid time and all that, so tuners will have no problem getting this to work. Dishworks makes the little other parts, so it drops right in. Really great injectors, really good price point. So really recommend it for this kind of use. We're also running a Fuel Lab upgraded fuel pump. Now this fuel pump can pump 340 liters per hour. It's more than enough to run an SR, or even if you're running E85. It's a good pump, a lot of capacity. It's compact. It'll fit into your stock hanger if you want to. It's also totally E85 compatible. A lot of pumps say they're E85 compatible, but we've been finding that a lot of them really still give problems further down. But this one's been validated with E85, so we know it won't have problems. So Fuel Lab is a great pump. I don't know if this is a scientific comparison, but if you pick up the Fuel Lab pump and you pick up some of the other ones that pump 340 liters per hour, the Fuel Lab one is really heavy. So it's not scientific, but it seems like maybe there's a lot of good stuff in there. It's just one of my observations. So the fuel stuff and the turbo is kind of mandatory if you want to make big bolt-on power. Now, this stuff is kind of optional, but we think that'll enable you to make more power with less boost, less stress on everything. I guess I'll start with the manifold because it's right in front of me, but we're going to be running a Greddy intake manifold. The Greddy manifold has a way bigger plenum and shorter runners. And we haven't exactly dyno tested the Greddy back to back yet, but we've done other manifolds that are very similar. And we found, 30 or 40 horsepower over the stock manifold at the same boost level. So I think at our lower boost levels that we're going to be running on this particular car, it's pretty safe to say that this is probably going to make between, I would say 15 or 20 more horsepower at the same boost level. So it's pretty much free power. The shorter runners could give you less torque, but we found on turbo motors that isn't usually the case. And the Greddy manifold's totally proven. Some of the things I like is the plenum is bigger, but it's not ridiculously big. So your throttle response and all that, and your boost lag will be probably the close to stock. So it's not like a drag-oriented piece with huge plenums and all that tend to be laggy. It's also good for top feed, like it's compatible with all the stock Nissan parts. So if you want to run a stock Nissan fuel rail, that's okay. We're going to be converting to top feed, but like if you don't have the money to do that right now, you can do it in a modular fashion. Another cool thing is all the stock throttle cable and all the throttle hardware bolt-ons. So there's No fabrication needed to get your throttle to work. And another great thing is your fast idle control and any of your vacuum things. There's a port for it on the bottom. There's also a few extra ones for your fuel pressure regulator, your map sensor, non-Nissan things. So all your Nissan stuff can hook up, and there's a few extra ports for your non-Nissan stuff in case you're running standalone and things like that. So in my eyes, this is free horsepower, more horsepower with the same amount of boost. That's always good. Less boost, less stress, less heat. So, I mean, that's the reason why I want to run this manifold. The next thing that I feel is pretty important is a really good front mount intercooler. Now, there's a lot of cheap intercoolers on the market for the S chassis. These usually use a bar and plate, kind of generic Chinese bar and plate heat exchanger. Bar and plates can be pretty good. You know, they can act like a heat sink. There's a lot of thermal mass to them. They're good for stuff like drag racing. They actually start cooling before there's like airflow from the vehicle speed. That's their advantage. Some of their disadvantages, though, is they're heavy and they don't allow air to penetrate the core really well. So the core is kind of restrictive in the airflow direction. Now, the Greddy manifold is a tube and fin. And for cars that drift and road race, the main reason why I like tube and fin is the air can penetrate the core, go through and cool, hit the radiator without like restricting too much. So it's important to have good airflow to your radiator to keep the coolant cool. You might give up a little bit of low speed initial cooling because it doesn't have the thermal mass. But once you get the car up to speed, you get airflow through the core. The heat exchange is really good, just as good or maybe even better than a bar and plate. One of the other reasons I like tube and fins for road racing and drifting is there tends to be less restriction through the core from a boost side. So there's less pressure drop across the core. So less pressure drop, less restriction to airflow to the radiator. That's why I like tube and fin. So road racing and drifting, you know, I like tube and fin. For drag racing, street use and all that, bar and plate's pretty good. And this isn't a hard, fast rule, but it's just my personal opinion, and a lot of people might disagree with me, but hey, that's what I think, and this is a pretty slick kit. So a good front mount. The other thing is, you know, there wasn't room on the table to show it, but you know, Greddy makes a really good hard pipe kit that goes with their intercooler. So it's all mandrel bent, big diameter. The stock stuff is small diameter, a lot of plastic and rubber, a lot of neck downs. You know, some people might find it hard to believe, but I found that like going to bigger charge pipes made out of a rigid material instead of a lot of silicone hose can be good for power. I mean, like I found, you know, up to 8 horsepower at the wheels just from getting more efficient charge pipes. So, you know, it's worthwhile. This is free power. It makes more power at the same boost level, same thermal load, so I'm all for that. We went to a Greddy air intake too. The Greddy air intake has these nice cast pieces that bolt straight onto the turbo. Some of them won't work with our Garrett turbo, but I just wanted to get this to show you. Being cast, it has like nice changes in cross section, minimum restriction, nice smooth bends that you can't get with you know, like fabricated tubing and silicone couplers. Really nice, really low restriction. The Greddy air filter is really low restriction. I'm not often a big fan of these foam type elements, so we may replace this with a, you know, like a K&N or something later. But I mean, this is a decent filter. It comes with a velocity stack thing, but there wasn't room on the table for me to show it. Another thing is the Greddy charge pipes is compatible with their blow-off valve. Now these blow-off valves are to protect your turbo from surge. When you let off the throttle, your turbo is producing boost, and then that hits the closed throttle blade, and the flow backs up, and your turbo surges, and that's really bad for your turbo, your compressor wheel, and your thrust bearing. What this does is it blows off into that condition and lets that excessive boost pressure off and makes that cool whooshing noise that all the racers like, but there's actual function. The other thing about having the blow-off valve is when you lift the throttle, your turbo doesn't go into surge and slow down. It keeps on spinning really fast, so when you get back into the throttle, you don't have as much turbo lag. Now, what I like about these new Greddy blow-off valves is they have a thing where some of the pressure inside bleeds to the other side of the diaphragm, so boost pressure actually helps hold the valve shut. Now before, if you adjusted these things all loose, there's a chance that at higher boost pressures, the turbo would blow them open and they would be a big boost leak. But these new Greddy designs, they're really ingenious. You can have a light responsive spring, but they stay shut even at high pressure. So it's one of my favorite blow-off valves on the market, and a lot of people don't know about them, but they're cool to get. Finally, there's stuff for the Valvetrain from Jim Wolf Technology. Now, cams aren't essential, but what we're trying to do is make power with the lowest amount of boost, so we don't have problems with overheating and the engine's all nice and happy. So we selected the Jim Wolf C1 cam, and for the SR, I mean, I like Jim Wolf cams probably better than any of the other ones on the market. The reason for that is for any given duration, Jim Wolf has the most area under the curve. And they spend a lot of time researching harmonics and surge and acceleration, so they can come up with the steepest low ramp rates and all that, and the highest acceleration possible to get the most area under the curve, which means the most power, the most flow, and you also have the best surge margin, so the least likelihood of valve float, and you don't have to go to super killer valve spring tension. So the C1s are pretty short duration and pretty high lift, but they also don't float that easily, which is important to the car with drifting where you bump the rev limiter a lot. To run the C1s, you have to run the Jim Wolf Technology springs. Now these springs are frequency matched to the cam, so run Jim Wolf. Don't use any other like general aftermarket double valve springs with higher tension, because these springs are matched to the cam and the cam is designed around these springs. It's all about harmonics and reducing surge. So these have fairly low tension, which is kind of weird, but when you design around the harmonics, you don't need killer tension. You get like some generic double valve springs or just springs from another manufacturer. They'll tend to be stiffer. You'll have more wear in your valve train, and it'll eat up more power, overcoming the stiffer springs. So match the JWT cams with their springs, everything's good. And the springs aren't that expensive either, so I think that's a good match. Now, if you don't have a lot of money, JWT makes excellent cams that work really good with the stock springs. They just have a little bit less lift. So they're actually designed around the harmonics of the stock springs also. So for running completely stock Valvetrain, they still have the most area under the curve, considering it's all stock stuff. So always, I think when it comes to cams, Jim Wolf Technology kind of rules the SR market. We also have Jim Wolf Technologies adjustable timing gears. For this turbo motor, we're not going to go too crazy because turbo motors don't like tons of overlap, but we're probably going to advance the intake cam a little bit to give us some more low-end torque and help spool the turbo up quicker. Might lose a little top end, but we really don't care on this particular motor. We just want it torquey and responsive and come off the corners well. Now the Jim Wolf cam gears are designed to actually not have the Allen bolts and the infinite adjustment. They're designed to be able to be adjusted in 2.5-degree increments by a combination of jumping teeth and putting it in different holes. And you can see that the holes are labeled and the teeth are labeled. You know, this is like CNC engraving, so it's not going to wash off or anything. And there's an instruction sheet that tells you how to do it. Now, this doesn't have the advantage of infinite adjustment, but it also means there's no adjusting bolts to come loose or slip and possibly destroy your motor. So this is like stock type bulletproofness and really low price. These are a lot cheaper than any other adjustable timing gears on the market. So if you have a good feel for what you got to do and you know what the car is going to respond to, I really like these gears just because there's a couple less failure points to happen. Now, I've seen the Allen bolt type adjustable timing gears come loose any number of times. You know, like if you're careful and are diligent about tightening them down and maybe Loctiting them and keeping an eye on them, you're not going to have any problems. But man, I've seen a lot of people mess that up, and I've seen engines damaged by those coming apart. So there you go. In my opinion, these are the basics for a solid full bolt-on engine. We're shooting for about 330, but we can go up to 400 with a different turbo choice. So, you know, for the T25 frame, they make a GTX 2871. That'll get you to 400 horsepower, or you can get a different manifold and, you know, go to a bigger turbo. But for our use, our power level, and the simplicity, the low price, and the reliability, I think this is the way to go. So stay tuned. We're going to have a lot more SR20 stuff in the future. Like I said, you can get a lot of power out of the SR20 stock bottom end without hurting it. And we're going to make it reliable and good power. If you like our content, be sure and subscribe. We'll have a lot more technical stuff coming up in the future, a lot more cool SR20 stuff. If you need parts for your project, check out our web store. Buy your parts from us. Our prices are competitive with most other people's street prices, and any money we make helps fund stuff like this so we can create more cool content for you guys. If you like our merch, you know, we have t-shirts, hoodies, and more designs than just this one that I'm wearing. Go to our web store, click on our merch, and you can be cool and have MotoIQ stuff. So talk to you next time about more SR20 bolt-on stuff, and hope you enjoyed this one.